Hello, everyone. So today we'll be continuing with functions for paper one. So today we'll be looking at question 4 from November 2017. So last time we looked at November 2016, question 4. So this is a different question. Last time it was an exponential function. Now we have a parabola or a quadratic function. So every time, so this is just simple. Given the equation f of x is equal to minus a x to the power 2 plus bx plus 6. So every time when you see something like this, you already know that since you have a negative here, you're going to have a function that looks like this, right? And at the top here, you have your turning point, your x values, and your y values, your x value and your y value. And if you want to go further, you already know that this x is equal to minus b over 2a. The y I'm not really sure, but I think it's 4ac minus b squared over 4a, right? But you don't need to memorize this. You can know this one, and then you use this function, substitute it into the original function to get your y. You can use that one to confirm this one, to confirm if that's true, right? So we have this. We already know that since we're given c is equal to 6, that this one is our y-intercept, right? So at our y-intercept, we have what? We have 0 and 6, because at the y-intercept, x is equal to 0, right? So from just looking at the function that we're given, we can deduce a lot of things. What the shape of the graph, and also the turning point, right? If we're given more, then we can deduce more, right? So since we have, let's just look at our question at our questions now, so we can get started on that. It says we need to calculate it says the gradient of the tangent to the graph of f at the point minus 1 and 7 over 2 is 3. Show that a is equal to 1 over 2 and b over 2. Okay, so let's get started on this. We'll answer our questions here. So what are we given? We're given that f of x, an ugly f, I don't like it, so let's just do like this. Yes, f of x is equal to minus ax squared plus bx plus 6, right? So given this, and then they're talking about the gradient now, we can determine the function of the gradient, which is f prime x minus, so here now that since we're just looking at functions, I'll just go ahead and write this. I will explain how we get the gradient to look like this when we look at calculus, but it's simple. You take this one, you take your exponent, you multiply it by this coefficient of your x, right? And then you minus 1 from exponent. So here it will be minus a multiplied by 2x to the power 2 minus 1 plus b multiplied by 1x 1 minus 1. This does not have an x, so because we're differentiating according to x, so this one will just be 0, and then you get what? You get this minus 2 ax plus b, right? So let's just move from there. Okay, so they say that at this one is equal to 3 at x is equal to minus 1 and 7 over 2. So already we know that we have an x there. So at x is equal to minus 1 over minus 1. Let's confirm, was that minus 1? Yes, minus 1 at the point minus 1 and 7 over 2. So we know that this will be minus 2a minus 1 plus b is equal to 3, because they said the gradient is equal to 3, and this is our gradient. So we have what? Minus 2 minus 1, we say we have 2a plus b is equal to 3, right? We can just and then from here, since we want to calculate for a and b, this is we have two unknowns here, right? So we can just have this as a equation 1. So let's look at what else can we do, right? So they said that we have minus x, and then we also have 7 over 2, right? We are given points of the graph. So the graph has points, so the point -1 and 7 over 2 lie on the graph, right? So we can just what? Sub this into f of x. So we'll have something like 7 over 2, this is your y, is equal to, so we had minus a into, so squared plus b into -1 plus 6, right? And then we have 7 over 2 is equal to, this will be to the power 2, so this will be positive, so you'll have negative a by positive 1, which is minus a, so you have minus b, you have plus 6, right? So we can just say take all of this side and take this that side, and take this that side, I mean. So we'll have a plus b plus 6 is equal to negative 7 over 2, and then oh, sorry, yes, that's a negative 6 because it's positive this side, so you will have a plus b. So that's much better to make your unknowns positive, so you can you can do the simplification very easily. So you will have minus 7 over 2 plus 6, which you can write as minus 7 over 2 plus 12 over 2, so that you can add these two. So you have what? 12 minus 7, that is 5, right? Because 6 and 6 is 12. So if you take the 1 from the 6, give it to the other 6, that's 7 plus 5. So you have 5 over 2. Therefore, a is equal, a plus b is equal to 5 over 2. We can simplify this by multiplying the whole thing by 2. So we're going to have 2a plus 2b is equal to 5, because 5 over 2 plus 2 multiplied by 2 will just give you 5, right? Equation 2. Since you have equation 2, you go back to simultaneous equations, which you can just do what? You can use two formulas: elimination, process of elimination, or substitution. Let's just use elimination. I'm sure you the last time you saw elimination was back in a grade 11 or grade 10, because most of the times in grade 12 we mostly use the substitution method. So you will have what? 2a plus b, sorry, because this is equal to 2 plus b is equal to plus 2b is this, and then you have minus what? 2a plus b is equal to 3, and then you will have your answer as this and this cancel out because they're the same, so you minus get 0, this and this, you get b is equal to 2, right? And they said you must prove that b is equal to what? 2. So already proved that b is equal to 2. And then your a, to get a, you can use either of these equations. So let's just use equation 1. So sub b is equal to 2 into equation 1, and then you will have what? You will have 2 sorry, you have 2a plus 2b, which will be a 2 by 2, and then you guess what? This is should be equal to 3, so you have 2a plus 4 is equal to 3, so you have 2a is equal to 3 minus 4, which is equal to negative 1. You divide the whole thing by 2, you get what? Therefore a is equal to negative 1 over 2, and b is equal to 2. Yes, so we know this is true because we're supposed to prove it, right? So we got our answers proven. Thumbs up. Okay, so we can look at the next question now, 4.2. So with 4.2, what they want us to do is they want us to calculate the x-intercepts of f. So let's go ahead and write our equation now. We have f of x equal to minus a, so that will be what? Will be minus into minus 1 over 2. All right. So sorry. So they said we have what? Oh, we get a is equal to 1 over 2. Okay. So I was confused. So let's see what happened next. So it seems like we did something wrong. We did do something wrong. here, all right? Because sorry about that, because this is plus b, right? This is equation 1. So we have what? We just have 2 is equal to 3. So we have and then we will have what? Can just let me just do this. So we have what? We'll have, because we take this to the other side, we'll have 3 minus 2, which is equal to what? 1. So now we divide by 2, 2, 2, right? Cancels. This one's cancel. A is equal to 1 over 2. So our A is just plus 2, which I can just say that, yes, this is, so we'll prove that A is equal to 1 over 2 and B is equal to 2. Sorry that's why you have to check your calculations every now and then, because it's very simple to make some subtle mistakes, right? So let's just do this. So this will be a negative because A, that side is given as negative A to the power 2. So we have 1 over 2 x squared plus b. B is positive, so this is 2x plus 6, right? They want us to calculate the x-intercepts. We know that at x-intercepts, y is equal to 0, right? So we can just equate our f to 0. So we have something like this. When working with equations, right, you wanna work with you wanna use whole numbers and not fractions, right? So that means that this one will have to turn this whole equation into whole numbers. It's better like that. It's much better. So you can multiply those whole equation by what? By minus 2, so that you can get rid of this 2 and this minus. So we'll have x to the power 2 minus, because this minus 2 by 2 you get 4x, minus 2 by 6 you get minus 12 is equal to 0. You can use the quadratic equation here to find your x values, which minus b plus or minus we have this square root ba squared minus 4ac over 2a, and then you can just substitute. You know how to use this. Everyone knows how to use the quadratic equation, so I'm assuming that. But you can also use what? You can also use, what is this? Factorization. So factorization is grade 10 and grade 11 work, maybe even grade 9. So you do need to know how to factorize. It makes life much easier. So you can see from here you have minus 6 is equal to 0, or x plus 2 is equal to 0. So that the reason we got this is that this x multiplied by x squared, x by 2, 2x, x minus 6 by x minus 6, 2x plus minus 6 minus 4, and then you multiply this two, you get this, so it checks out. And then your x-intercepts, you can write it their coordinates as what? At let's wait and just write this x first, and or x is equal to minus 2. So you can write your coordinates as minus 2 and 0, and then 6 and 0. Okay, so these are x-intercepts. And then 4.3 wants us to calculate the coordinates of the turning point. So the way you calculate the coordinates of the turning point, there are many there are many methods to do this. You can complete the square and then write your function as what? A x plus q plus p to the power 2, and then you have q. I think it's minus. Yeah, I think it's minus here. Minus p to the power 2, and then you have q. These are your turning points, right? And then but when you, since we have a function up here, you can just complete the square of this one, write it like this, and this will be a turning point, right? So that's kind of long, so let's just use the simple one. We already know that the x value is equal to minus b over 2a. This is at the turning point, right? You can also get this by let's look at this from here, right? Because we know that the gradient is 0 at the turning point, so this will be equal to 0, like this, equal to 0. B comes this side, so you will have what? Minus 2ax equal to minus b, divide by minus 2, you will have what? X is equal to b over 2a, and then you have your x value at the turning point where the gradient is equal to 0, right? So that's where that equation comes from. Oh, okay, pardon me, it's b over 2a. So let's just make sure to confirm that is true. Oh, yeah, it is minus, it is minus b. This is a case where we have negative, but let's just use this one, right? Let's just use this one. So we'll have so let's just do that. So let me just say at turning point, um, x is equal to minus 2ax plus b is equal to 0. Therefore, x is equal to this negative, so you divide by negative, that will be positive, so you have 2a. So we know that b is what? Is 2. We calculated a as minus 1 over 2. So this by this will be this will be what? 2 by minus 1 over 2. So you therefore get your x value as been what? Has been why does this give us let me see. So this will be so let's see, minus 2, right? Minus, and then you divide, you get a positive. Therefore, your x, I'm trying to see if I'm not making mistakes, right? Because I don't want us to go back when we make mistakes and then realize that we messed up somewhere. Because the thing is, I'm confused as why are these two, having the same coordinate? Because what I know, the other way to get a turning point is you can just take an average of this, where you have minus 2 plus 6 over 2. So this will be what? Will be a 4 over 2. So your our turning point should be 2, which makes sense. So it should be a positive 2. Alright. So here I'm failing to understand why do we have this. So let's just make this simple, right? Let's just make this simple. Please bear with me. Please bear with me. I'm trying to get it right so that I don't make mistakes, because I don't want you to write something wrong. So let's just find our so we know that this one is minus 2a x plus b, right? This is minus 2 into minus 1 over 2 plus 6. So therefore fx is equal to, this will be what? So this is there's an x here, and then you add your 6. So this will be what? Positive. So you will have an x, right? No. My problem, I don't know why I'm making 1 over 2 negative. So that is the problem. I don't know why I'm thinking that it's negative, because it is positive here, right? I don't know where my mind is. So we have minus x plus 6. Yes, minus x plus let me see. This b is not 6, it's 2. Yes. Okay. So we know that this is equal to 0 at a turning point. We're spending too much time on 4.3. So therefore, we know that x is equal to what? Is equal to 2, because you can take this to the other side and then you're left with that, right? So this is the learning curve. Actually, what I'm doing here is actually how you learn, right? You make mistakes, and then but realizing your mistakes and picking yourself up is what you need to do, right? So we can sub x is equal to 2 into y to get into f to get the y value at x is equal to 2, which is your turning point. So you have this. So you have minus 1 over 2. That's our function. So you have 2 to the power 2 plus 4 no, is it plus 4? Let me just check. It's plus 2. It's plus 2. Checking is better because then I prevent mistakes, right? So this will be a 4. So this will be 1 over 2 by 4 plus 4 plus 6. This will be what? Minus 2 plus 4 plus 6. So this will be what? This will be 8 because this gives you 10 minus 2, so you get 8. So your turning point is what? Is 2 and 8. Therefore, we can have this turning point 2 and 8. So I can go ahead and remove this for now. We'll get to that at a later stage. So this is your turning point that they wanted us to calculate. So now we can look at 4.4. So what they want us to do in 4.4, they want us to just sketch the graph of f, clearly indicate all intercepts with the axis and turning point. So let's just sketch the graph. Okay, let's just use a pencil for this. Yes, okay. So let me just do this. See, okay. Right, yes, to now make it nice. Okay, I'm giving myself space at the top and also on the right because I'm already aware of how the graph should look like from our coordinates, right? So we have to indicate the x-axis, the x-intercepts, which were minus 2 and 0, 6 and 0. So we can just put minus 2 here, minus 2 and 0. And then we can just say this is 2, this is 4, this is 6. Graph will be a little bit big, but that makes things much easier because you can see it how it looks. So let's just do that, and then we put our y-intercept, which was 6. So let's have the same distance with similar distance around here. I will just have 6. Oh yeah, let's indicate this is the y coordinates, x coordinates, x-axis. And then we have our turning point. Let's just say this is 2, and then yeah, let's just put it around here. So here we have 2, and then yeah, this can just indicate this as the coordinates because we already know that the y is 0, so there's no need to indicate it. And then here we can just indicate that we have an 8 right before, yeah, so this is our turning point. So we'll have what, 2 and 8, right? And then I can just use a blue to draw my graph. So it has to cut here and also touch here and turn around here. So we can start by drawing the first half, cut the y-axis there, cut the x-axis at 2, and then it goes to infinity here, and then it does the same thing this side, but it cuts 6, and then it goes in this direction, right? And so we can indicate that this is our f of x, but I could have done better. I could have written it much nicer, you see, drawn it much nicer, you see, but we clearly indicated our intercepts, which we have minus 2, minus 6, we have 6, minus 2, 6, and so we can also indicate here that this is minus 2 and 0, this is 6 and 0. Our turning point we indicated, we indicate that this is 0 and 6, right? All of our intercepts and the turning point were indicated, right? So we can go to 4.5. So what they want us to do in 4.5 is to use the graph to determine the values of x for which f of x is greater than 6. So let's get to it. What does it actually mean when they say that the f of x is greater than 6, it's a graph. How can it be greater than 6, right? So we know that f of x, right, these values are our y values, right? So we need the x values for which the y values are greater than 6. What does it mean? So our y values of f greater than 6, right? So let's just draw a line. I'll use this. So let's just draw a line. This is our y is equal to 6, or f of x is equal to 6. What we want, what are values that are greater than this line? Of this value, these are values of x that are above the line y is equal to 6, right? And these values that are above this line, where do they occur, right? They occur from x is equal to 0 to x is what? I'm not sure. This side. You see, so we have an x value somewhere here. We're not sure of it. We'll have to calculate for it, right? So where do we have? So we can calculate that x value by saying, so because y is equal to 6, right? So one of the x values y and y is equal to 6. That's 1 over 2 x squared plus 2x plus 6 is equal to 6. This side you will have a 0, so have 1 over 2 x squared plus 2x is equal to 0. Factor out x, divide by it, you will have what? 1 over 2 x plus 2 is equal to 0, and then you multiply the whole thing by minus 2, you will have x, and then you will have what? 4 is equal to 0. Therefore the value is x is equal to 4, right? You can do this very, very fast. So our value here is x is equal to 4. So for values of for y values greater than 6, the x values for where that occurs are between what? Are between 0 and 4, right? Are between 0 and 4. But is it greater or equal to 0, less or equal to 4? We'll come back here. It's only just greater, so it's not greater or equal to, right? Because at 0 the y is equal to 6, at 4 the y is equal to 6, right? So it cannot be, so one values that are greater, not greater or equal to. Therefore our solution will be x. Let's continue with let's just write with that. It's fine. So it will be this between 0 and 4. That's why your graph is above y is equal to 6, right? So let's go to the second question. So we can come back to this one to discuss questions like this at a later stage. If that's necessary, you can comment. So they say sketch the graph of g of x, which is equal to minus x minus 1 on the same set of x's as f. Clearly indicate all intercepts with the axis, right? So let's do this. So g of x is equal to minus x, right, is equal to minus x minus 1, right? We can calculate the x-intercepts for this one, so we can just do this very fast. We know that y is equal to 0. If we equate this to 0, we'll have minus x minus 1 is equal to 0. We can just take that the other side. So let's just do this very fast. X minus 1 is equal to 0, minus x is equal to 1. So you have x is equal to what? Minus 1, right? So your x-intercept, you have minus 1 and 0. Your y-intercept, you know that x is equal to 0, so you will have just 0 and minus 1, right? So that's what you have. So we can draw it here. So since we have a negative x, we know it's a negative gradient, so it has to go to the left or leaning towards the left. So let's just go ahead and draw that. Let's just use a different color. Let's make this purple. It cuts the graph at what? Minus 1. at -1 and 1, and we also have this negative. So when I have it cut around here, say this is our -1 and also this is -1. So we'll have it move like this, right? We'll have it move like this. So let's just on this stuff, sorry, uh, just grab it and put it like this. Yes, just like that. So this is -1, this is -1. So we can indicate this intercept, because it says indicate intercept with x-axis. So we maybe don't need to do that, but yeah, so let's just move. But you can get that this intercept here by equating these two functions. So that is f and this is g of x, right? Just say f of x is equal to g of x and then solve the equation, find your intercept. So 4.7 wants us to what is it? Oh yeah, clearly indicate all intercepts with the x-axis. Is it not the intersections? They didn't say anything about it, and then we have 2 marks for x-intercept, y-intercept, and the graph. Write down the values of x for which f of x by g of x is less or equal to 0. So let's get to that. That's another equation that's similar. That's another equation that's similar to 4.5. So less or equal to 0. So what this actually means is that the y values of f multiplied by the y values of g, they should give you an answer that is positive or above 0. See, that's above 0, equal or above, oh sorry, it's equal or below 0, because this is below, right? Or below 0, so that's or negative, right? Negative values. When do you get a negative answer? When you multiply two things, right? You get a negative answer of 0 when you multiply a positive by a negative. See, so it means that where these two have different signs, we should be looking there, right? So in these equations, what we're actually multiplying, because we can't multiply each and every value of f and g, we just look at what signs. Is f positive here? Is x, is g positive here or negative? So let's just go back to the graph to make this much better. So I'm using a different color than what I've used before to draw. So let's see. Let's look at where we have a change in. Let's guess we have a change in what and signs, right, from both graphs. So actually it occurs so many times. We have a change of sign around here. We have a change of sign around here. So this is x is equal to -2, x is equal to -1, and we'll also have a change of sign around there, x is equal to 6. So we'll look where there's a change of sign of each graph. So we'll look here below this side where we have minus x, to that side we have what? We have our f and then we have our g, that side. This is negative, but g is positive. When you multiply these values and these values, what do you expect? A negative answer. And since f is 0 at x is equal to -2, when you multiply 0 and any value that you have here, which is a positive on that side, you get what? A 0. So we already have a solution. So let's add our solution. X is less or equal to -2. That's what we use signs, right? And then we just go between -2 and -1. What do we have? We have f, which now has changed sign to be positive, so it's positive, positive, positive. But what do we have from g? G is still positive because it's above 0. So we don't have a solution there. We have positive signs from x, from F and from G. So what do we have? We don't have any solution there, right? So we'll move to the next one. So between -1 and 6, what do we have? We have G, which has changed now. It is now negative, right? We indicate that, but your F is what? It's still positive because it's above 0. Positive, 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 0, right? So what do we have? Okay, when you multiply this and this, you get a negative answers. We have a solution here, right? So we have a solution, and you can say and, or maybe or, because we have solutions there. So you have 6, and then you have what? -1. But we also need to indicate this because we're also including where when you multiply these two, you get 0. And that's our solutions, right? When you look at multiplying two functions, you look at their signs. What does the sign say? So you can do something like this, where you look at where there's a change in what? There's a change in sign from a graph, one graph or the other graph, and then you just indicate. You have positives, you have negatives, right? And then you just do that. Oh yeah, I forgot to look at this, where you have greater than. So this will extend like this, right? And this is negative now, and this one will continue as negative. So we have no solution where we have x is greater than 6, because they are both negative. You have a positive number if you multiply those functions, right? That's it for these questions. Let me know if you need anything or clarification in the comments below. So yeah, that's what we had. I think that looks good. That looks good. Yeah. So let's just try to cut time very short. I've already spent a lot of time here. So yeah, yeah. So I won't be going through this, but if there's anything, just mention it in the comments, and then I'll explain further to clarify anything or any misconceptions